So first, I would like to share with you some key concepts of light microscopy. And I will also repeat these at the end of the course because I think these are important concepts. So the first one is segmentation. We have already spoken about segmentation yesterday, and I hope that some of you probably knew about segmentation and others not. So just to summarize what it is, this is one of the keys to image analysis, not the only one for sure, but it is one of the major keys to image analysis. So I want to mention it at the beginning of the course, because throughout the course, we're going to say, oh, I want to segment this, I segmented that stuff, and then, you need to know what it is. So I want to remind you that the goal of conceptualizing a microscopy experiment and growing animals and cells and collecting all these samples that you're collecting, and also perfusing and cutting the sample and fixing it, staining it, acquiring images, and designing and running also the image analysis. The goal of all this is to extract numbers from the images for scientific comparison. Okay, that's what we want to do. So the most challenging step in many image analysis pipelines, not all of them, again, there are some other ways to image, but many, I would say most of the image analysis pipeline, is the segmentation step, okay? So what is this? Because what we want is to extract numbers, and so we want to analyze the images. We need to segment the images. So segmenting means separating individual objects or areas. I think I'm going to try and see if I can get a better pointer. Maybe not. Okay. Do you guys see my mouse?
Yep.
Yes. Yes.
The most challenging step in many image analysis is segmentation, and segmentation means separating the objects or area, individual, from the background. So segmenting an image means creating on top of the image a mask that only shows the areas you're interested in. So let's say this is the original image that we have, and here we say, hey, these little vesicles are interesting, but the stuff that is in here in between, and also the black there, this is not interesting. So I'm going to say, oh, these things is my signal. This is my background. This is background, okay? And what I only want to analyze this. So I create this, which is a segmentation mask, which only, if you want, you can see it as a little hole in a cardboard paper, little holes that allows us to see only the areas of interest. And so when I put the segmentation mask on top of the image, all I see is the signal that I'm interested in. This is a segmented image. So this process is called segmentation. And so you will know now that throughout the course, when we're talking about, oh, I need to segment that, or I'm doing some segmentation, or it's difficult to segment, this is what we mean. We mean creating this mask. So what are the challenging key concepts in microscopy? They are first some artifacts of microscopy. And so refraction, bleed through, and saturation and underexposure and undersampling lead to artifacts in microscopy. And so we're going to deal with all this and understand what they're doing and how we can tackle them. Not everything today, but several of them today. Then another concept that is challenging is that the final resolution in the image depends on several things. So it depends on the objective and the light, the wavelength of light that you're using to image, and this is what we call the optical resolution. Okay, throughout the course we'll call this optical resolution. It also depends on the image pixel size. So that is a little bit of a challenging concept as well, because people know about that one, but they don't think so much about the second one. This one we call throughout the course the digital resolution. And then it also depends on the contrast. And that depends a lot on the sample quality. So we will talk about all this during the course, but it's a little bit a challenge to think that actually there are several resolutions. And what we're interested in is what is the final resolution in the image. So we have to consider everything. And then, as I also mentioned yesterday, we need to reverse think our experiment. Number one, what do we want to measure? What are the metrics that we want to extract from the image? And then also, how will you analyze the image? The way you analyze the image influences what you can measure in the image. And how will you, and from there you can deduct how will you design your sample, and also which microscope you're going to use, which objective, and which imaging settings you're going to use. So we start with what we want to measure, and when we deduct the rest. This is reverse thinking your experiment. It's really important to go through this process. One thing that is, I hope that you will grasp before the end of the course, is that the image of an object is never and cannot be like the object. Okay, so I repeat that one. The image of the object, the image that we are acquiring of the object, is never like the object. It is not never identical to the object. Okay? What we image is the interaction of light with the sample and with the microscope elements. So we do not, what we're seeing when we acquire our image is never like the object, right? So we have to design our scientific questions with keeping in mind the limitations of the microscope. So I'm going to have now a lecture explaining some behaviors and properties of light so that we can understand better this statement.